Something happened 3 weeks ago that I did not anticipate, with the specific confidence that the claim I am about to make requires, because the claim that switching your development environment from one operating system to another doubles your productivity is the kind of claim that the technology content ecosystem produces in abundance, without the specific, measurable workflow by workflow evidence that distinguishes the genuine productivity transformation whose documentation serves developers making platform decisions from the advocacy-motivated performance comparison, whose conclusion was determined before the comparison was conducted, and whose methodology was designed to support the predetermined conclusion, rather than to honestly evaluate the question that the comparison's framing suggests it is answering, something whose occurrence I can document in the specific terms that make it verifiable rather than assertable in the metrics, that I tracked before and after the switch rather than in the impressionistic sense that things feel faster and smoother, that technology platform advocates invoke when they want the credibility of productivity claims without the accountability of productivity measurement, and that the developers whose Windows development setup resembles the setup I switched from, whose daily experience of their development environment includes the specific friction points whose accumulation I had been accepting as the normal cost of professional software development on Windows, rather than recognizing as the specific cost of professional software development on Windows in particular, whose elimination was available through the platform switch, whose productivity implications I'm about to document in the terms that make the documentation useful for the developer, whose platform decision it might inform, rather than for the content creator whose engagement metrics it might improve, are the developers for whom this account of 3 weeks of Linux development is written, and whose reading of it should be informed by the specific methodology, whose application produced the specific findings, whose communication is this examination's purpose. I switched my entire development setup from Windows to Linux, and my productivity doubled in 3 weeks. Not in the vague, unverifiable sense of having subjectively experienced the new environment as more conducive to focused development work in a way that the psychology of novelty and the confirmation bias of a decision already made could plausibly explain without any genuine productivity improvement having occurred. Not in the cherry-picked best-case scenario sense of having selected the specific development tasks whose performance on Linux is most dramatically superior to their performance on Windows, and presented the comparison of those selected tasks as representative of the overall productivity difference when a more complete selection of tasks would have produced a less dramatic comparison. In this specific, task-tracked, time-measured, output-counted sense that I measured the time required to complete, defined the development tasks before the switch, measured the same metric for the same categories of tasks after the switch, and found that the combined effect of the specific improvements, whose individual contributions this examination will document, produced a measured productivity increase across my complete development workflow, whose magnitude, when calculated from the time measurements rather than from the subjective impression that the time measurements informed, was a doubling of the development output that the same hours of work produced in the 3 weeks after the switch, compared to the 3 weeks immediately before it. The switch was not planned with the advanced preparation that technology writers whose job is advice-giving recommend when they write about operating system migrations. In the careful, phased, parallel environment approach that minimizes the risk of productivity disruption during the transition period by maintaining the prior environment while building the new environment and switching individual workflows one at a time, rather than performing the complete replacement that my switch involved. It was prompted by the Windows 11 update that broke my development environment in the specific ways that the preceding analysis in this series documented, whose occurrence on a morning when a deadline was 2 days away and whose remediation through the documented fixes consumed 6 hours of the productive work time that the deadline was demanding, transformed the theoretical case for the platform switch that had been building across the months of accumulated Windows 11 development environment frustrations into the operational decision whose execution began that afternoon with the Ubuntu installation on the machine where the broken Windows 11 development environment had just demonstrated with maximum inconvenience the cost of continuing to build professional work on a platform whose architectural decisions were being made in directions that did not treat my development workflow stability as a primary constraint. Here is exactly what doubled, in the specific terms that make the doubling comprehensible rather than credible only through trust in my reporting of an impressionistic experience. Here is what each component of the improvement contributed to the total productivity increase, with the specific before and after measurements, whose comparison produces the aggregate doubling figure. Here is what the transition actually cost in productivity terms during the adjustment period that every platform switch requires, because the honest account of a productivity doubling platform switch includes the productivity cost of the switch itself, whose acknowledgement is necessary for any developer evaluating whether the long-term productivity gain justifies the short-term productivity cost that the transition period represents. Here is which tools I used, which configuration decisions I made, which initial assumptions about what would be difficult turned out to be wrong, and which genuine difficulties I encountered whose resolution required more effort than I had anticipated. And here is the honest assessment of which developer profiles are most likely to experience productivity improvements similar to what I experienced, and which developer profiles are most likely to find that the productivity improvement does not materialize or is offset by transition costs that their specific development workflows and tooling requirements create. The first and largest component of the productivity doubling was the elimination of the environment management overhead that Windows 11 development had required, whose accumulation across a typical development week I had never measured in aggregate until measuring it became the methodology whose application revealed its magnitude. Environment management overhead, in the context of Windows development, is the category of development time consumed by activities whose purpose is maintaining the development environment in a state where it supports productive development work rather than by the development work itself. And it includes update-related breakage investigation and remediation, WSL configuration maintenance, when WSL updates change behavior that development tools depend on, Windows Defender, exclusion management for development directories, whose scanning by real-time protection introduces the file operation delays that certain development workflows make visible as significant latency in operations that should be near instantaneous, Docker desktop performance issue investigation. When Docker's Windows implementation introduces performance degradation, that investigation reveals is a Windows-specific behavior without Linux equivalents. The collection of smaller configuration maintenance tasks, whose individual time costs are each minor, but whose aggregate represents a substantial portion of development time, whose consumption produces no development output. In the 3 weeks before the switch, I tracked this environment management overhead category explicitly by logging each instance of environment maintenance activity with its duration. The aggregate across 3 weeks was 11 hours and 40 minutes of development time consumed by environment maintenance rather than development output. Against the approximately 90 hours of total development time that 3 weeks of full-time development represented, environment management overhead consumed 13% of my development time, producing zero development output. The equivalent measurement in the 3 weeks after the Linux switch was 40 minutes of environment maintenance time across the entire 3-week period, which was the time spent configuring a system font, rendering setting whose default Ubuntu configuration I preferred to customize and updating a shell plugin whose changelog I reviewed before applying the update rather than applying it automatically. The difference between 11 hours and 40 minutes and 40 minutes in the same 3-week period for the same category of activity is a difference of 11 hours, which represents more than 12% of total development time returned to productive development work whose effect on output across the remaining development time is the first and largest component of the productivity doubling that the aggregate measurement reveals. The second component was the terminal environment improvement, whose magnitude I had underestimated before experiencing it, because the difference between using a Linux terminal natively and using a terminal in the Windows environment, whether through WSL, through Windows Terminal with PowerShell, or through the Git Bash environment that many Windows developers use for Unix-style terminal work, is a difference that descriptions of as marginal are accurate when describing individual operations, whose individual execution time difference is measured in milliseconds, but that compound into a substantial productivity difference when the development workflow involves the terminal interaction frequency that command line intensive development practices produce across a full working day. The specific terminal improvements that contributed to the productivity difference included the elimination of the path translation overhead that cross-environment terminal operations in Windows require. When commands reference file paths that need translation between Windows path formats and Unix path formats when crossing the WSL boundary, whose absence from the native Linux terminal eliminated a category of subtle friction whose magnitude was not apparent until its absence was observable in the fluency of terminal interaction that native Linux development produced. The Bash and ZH configuration responsiveness on Linux, where the shell startup time and the command execution time are the execution times of the shell and the command, rather than the execution times, plus the virtualization and translation overhead that WSL adds to shell operations on Windows, produced a terminal interaction speed, whose improvement over the WSL terminal experience was perceptible in the rhythm of terminal-intensive development workflows, in a way that the millisecond-level individual command speed improvements would not suggest was perceptible, but that their accumulation across hundreds of daily terminal interactions makes perceptible in the aggregate experience of terminal-based development work. The shell scripting component of my development workflow, which includes the build scripts, the deployment scripts, the test runner scripts, and the environment setup scripts whose execution is part of the regular development cycle, executed on Linux without the Windows-specific compatibility issues that WSL's Linux environment sometimes produced for scripts whose behavior depends on file system assumptions, line ending conventions, or system call behaviors that differ between WSL's Linux environment and a native Linux environment in ways that script debugging on WSL had introduced as an intermittent category of development friction. On native Linux, scripts that had occasionally required Windows-specific workarounds or WSL-specific compatibility adjustments executed without requiring those workarounds, because the environment for which the scripts were written and the environment in which they executed were the same environment rather than the compatible but not identical environments that WSL's Windows-hosted Linux creates. The third component was the Docker performance improvement, whose magnitude was the component I had most strongly anticipated, based on the documented performance difference between Docker on Windows and Docker on Linux, and whose actual magnitude in my specific development workflows matched the documented difference in ways that the skepticism about technology comparisons that content optimization has justified is appropriate. To note, did not cause me to anticipate incorrectly in this case. Docker on Linux runs containers natively on the host kernel without the virtualization layer that Docker Desktop on Windows requires to run Linux containers on a Windows host, whose absence from the Linux Docker configuration eliminates the performance overhead that the virtualization layer introduces for container operations, including container startup, file system operations within containers, and network operations between containers and the host system. The specific Docker performance measurements I recorded before and after the switch for the containerized development workflow, whose Docker-intensive character made it the workflow most directly affected by the Docker performance difference, included container startup times that decreased from an average of 12 seconds for the development environment container, whose startup time I measured across multiple instances before the switch to an average of 3 seconds for the same container on Linux after the switch, a 4 times improvement in container startup time that compounds into a meaningful time saving across the multiple container restarts that a typical development session involving active container configuration changes requires. The file synchronization between the host file, system, and container volumes, whose Windows implementation through Docker Desktop had introduced the latency that made certain development workflows that depend on fast file synchronization between host code changes and container-hosted application reloads frustratingly slow on Windows, performed on Linux with a near-native speed that the absence of the virtualization layer's file synchronization overhead produces, restoring the fast reload cycle whose developer experience value for development workflows using hot module replacement or file watching development servers is the value of immediate feedback on code changes. The fourth component was the cognitive overhead reduction that the Linux development environment produced compared to the Windows development environment, which is the component whose measurement is most difficult because cognitive overhead does not produce a logged time entry in the same way that environment management overhead does, but whose effect on development productivity is as real as the measurable time components, even when its magnitude can only be estimated rather than measured. Cognitive overhead in development environments is the mental load that the environment itself imposes on the developer, in addition to the cognitive load of the development work. And it includes the background awareness of whether the current environment state is reliable or whether an update might have changed something, the working memory occupied by the Windows-specific knowledge that Windows development requires, that is itself, and the context switching between the mental model of the Linux environment, where most development tools originate, and the Windows environment, where those tools run through compatibility layers, whose behavior requires maintaining a dual mental model of how things should work in Linux and how they actually work in the Windows context. The Linux development environment reduced this cognitive overhead in ways whose practical effect was the availability of more of my cognitive capacity for the development work itself, rather than for the environment management that Windows development required. When I ran a command in the Linux terminal whose behavior I expected based on the command's documentation written for Linux, the command behaved as documented, rather than producing the Windows-specific variation whose documentation I needed to locate. When I installed a development tool whose installation instructions described a Linux installation process, the Linux installation process was the process I executed rather than the process I executed after finding the Windows-specific installation instructions, that the Linux installation process the documentation described would not produce working results on. The correspondence between the documentation of the tools I use and the environment in which I use them that native Linux development provides eliminated the translation layer that Windows development had required between the canonical tool knowledge and the Windows-specific application of that knowledge. The transition period, whose productivity cost the honest account of the productivity doubling, must include lasted approximately 5 days, whose development output was below the pre-switch Windows productivity baseline rather than above it, representing the productivity investment that the transition required before the productivity gains that the Linux environment produces were sufficient to overcome the learning costs of the new environment. The specific challenges that produced the transition period. Productivity cost included the reconfiguration of the development toolchain whose Linux installation required the specific installation commands and configuration steps that the Linux versions of the tools use, whose differences from the Windows installation procedures I had memorized required the documentation research that tool installation from documentation rather than from memory requires. The font rendering configuration, which is the most frequently cited aesthetic challenge of the Linux desktop transition among developers whose Windows experience has calibrated their expectation for font rendering to Windows clear type rendering rather than Linux's free type rendering, required approximately 2 hours of configuration work to achieve the rendering quality whose visual comfort for extended development sessions I required, through the configuration of free type rendering hints, subpixel rendering settings, and font substitution rules, whose adjustment to the specific display hardware's characteristics produces the rendering quality that the correct configuration achieves, and that the default configuration of some Linux distributions does not produce without the adjustment that knowing what to adjust requires. The keyboard shortcut recalibration required a longer period of adjustment than the tool installation, not because the Linux equivalents of Windows keyboard shortcuts are significantly different, but because the muscle memory whose overriding requires conscious attention to what was previously automatic, rather than additional knowledge. Acquisition is the type of learning whose timeline is determined by the frequency of the practiced behavior, rather than by the complexity of the new behavior. After 5 days of daily development work on Linux, the keyboard shortcuts whose Windows versions my muscle memory had automated had been substantially replaced by the Linux version's automation in the contexts most frequently encountered, with the remaining Windows shortcuts appearing in the less frequently accessed functions whose automation on Linux built more slowly due to the lower frequency of practice. The application ecosystem gap that the Linux transition opened was smaller than the Windows development experience had suggested it would be, because the estimate of Linux's application gap that a Windows developer forms from within the Windows ecosystem tends to be formed from the set of Windows applications, whose Linux equivalents are most commonly discussed as absent rather than from the complete assessment of the full application set that the specific development workflow actually uses. The professional applications whose Linux equivalents I needed to find for my specific development workflow were found in every case. With the transition from Windows versions to Linux versions of development tools, communication applications, browser applications, and the other software categories that professional development requires, representing a combination of identical applications available on both platforms, open source alternatives whose capability matched the Windows applications they replaced, and web-based tools whose platform independence made them available on Linux without any equivalent transition requirement. The 3-week productivity measurement, whose aggregate revealed the doubling was not a measurement conducted under optimal post-transition conditions, whose result would not represent the ongoing productivity after the novelty effect of the new environment had dissipated. It was conducted across the 3 weeks immediately following the transition, whose first 5 days included the below baseline productivity of the transition period, whose inclusion in the 3-week measurement means that the doubling was achieved despite the productivity cost of the transition period, whose inclusion in the measurement makes the doubling figure more conservative than it would have been if the measurement had begun after the transition period's completion. The ongoing productivity measurement that continues beyond the 3-week period of the initial measurement has not revealed a regression toward the Windows productivity baseline that the novelty effect hypothesis would predict if the productivity improvement were novelty-driven rather than environment-driven, providing the persistence evidence that distinguishes genuine productivity improvements from novelty effects, whose duration is the duration of novelty rather than the duration of the improvement's cause. The developer profiles most likely to experience productivity improvements comparable to what this account documents are the profiles whose specific characteristics align with the characteristics whose presence, in my situation, produced the productivity improvement. Command line intensive development workflows whose frequent terminal interaction makes the terminal environment quality a significant productivity. Determinant are the workflows most likely to benefit from Linux's native terminal environment quality advantage. Docker-intensive development workflows whose container performance dependence makes Docker's virtualization overhead on Windows a significant workflow constraint are the workflows most likely to benefit from Docker's native Linux performance advantage. Development workflows that involve significant shell scripting whose Linux compatibility requirements have been producing Windows-specific workarounds are the workflows most likely to benefit from the elimination of the Windows compatibility overhead that native Linux script execution removes. The developer profiles least likely to experience comparable productivity improvements are those whose specific tooling requirements create genuine Linux application gaps, whose bridging requires the application compatibility layer solutions that introduce the friction and instability whose elimination in the core development environment was the primary source of the productivity improvement, whose introduction for specific necessary applications would offset the gains in the core environment. Developers whose workflows require Windows-specific applications without Linux equivalents, whose capability matches their Windows version's capability for the specific functions the workflow requires, face the genuine platform trade-off that the honest assessment of the Linux productivity case requires acknowledging alongside the productivity improvements that the switch produces for workflows without those requirements. The development environment that I deleted from my machine 3 weeks ago was not a bad development environment in absolute terms. It was a development environment on a platform whose architectural evolution was moving in directions that the March 2026 updates breakage had demonstrated would continue to impose costs on my development productivity that the platform's benefits did not offset. The development environment that replaced it is not a perfect environment. It is an environment whose imperfections are the imperfections of a tool whose design philosophy places my development productivity at the center of its architectural decisions, rather than treating my development productivity as the framing within which commercial and strategic requirements are satisfied. That difference, measured across 3 weeks of daily development work, is worth exactly what the measurements say it is worth, which is a doubling, not of effort, of output, from the same hours, on the same hardware, with a different operating system making different architectural decisions in service of different priorities. The terminal is open, the environment is stable, the update that broke nothing installed this morning while I was making coffee. And the productivity that the numbers reflect is the productivity of a developer whose environment is working for them, rather than a developer whose environment is working for someone else's commercial program. The difference is measurable. I measured it. 3 weeks of measurements say it is worth exactly twice what you are currently producing. The installation takes an afternoon. The productivity starts the morning after, and it compounds from there.